Thank you again for joining us today in today's session. So, in this session, we will explore some real world attacks, techniques, and more importantly, like how to defend against these preventive, the lateral movements. So, and towards the end, we'll also have a short demo on, we'll show you how the lateral movement can happen in a cloud environment. All right. So yeah, feel free to ask any questions at any point of the presentation if you have. And yeah, so before we dive in, I would like to hear your thoughts or understanding of what lateral movement is. So any thoughts or any suggestions, any ideas from anyone? Maybe you can drop it in the chat or when you can unmute. I just wanted your ideas on it. Okay, okay. Let me give a brief intro on that. So lateral movement refers to the tactics that the attackers use to move from one resource to other after gaining the initial access. So they what they do is they initially gain access to one of the resource and then they extend control over multiple resources and systems within the cloud environment. Let's understand this lateral movement in a cloud security through a simple analogy, maybe. So imagine the cloud environment as a large multi-room hotel, as we see in this picture. So each room in this hotel represents a different cloud resources, like maybe it could be an instance or a database or even the entire cloud account itself. There are multiple accounts. Okay. So now picture a thief who managed to sneaks into the hotel, and if each room has no internal locks or if the security is weak, the thief can move freely across all the rooms from one room to another, maybe, and going without any restrictions. Right. So maybe now let's take one step forward. Imagine that one particular hotel room contains the master keys to the other rooms. Maybe it's a management room or maybe it's like a safety deposit room or something like that. So if the thief gains access to that particular room which has privileged credentials or privileged keys, master keys to all the other rooms, then it's like a game over, right? So they now control the entire hotel and can access even the most secure room without any challenges, right? So this is exactly what lateral movement means in the context of cybersecurity. So it's the attacker's ability to move sideways without your knowledge and within your network. And once they breach a single entry point, they can enter into the next entry point without any hassle. So how does a hotel prevent this? Well, they just don't, put a board called "Do Not Disturb" and on a signboard, and they don't call it a day, right? So what hotel does to defense is, maybe I can call it as a defense in depth approach. So I will compare this with our environment as well. So in hotels, what they do, they install the surveillance cameras to monitor who's going where and to find any anonymous activities of anyone, right? So similarly, in our environment, we can use monitoring and logging systems in cloud environments. And in hotels, they provide key cards and they only open specific rooms, limiting access based on the roles, right? So just like that, we can have IAM policies or least privileges access controls in the cloud. And they often have restricted zones. We see more restricted zones in the hotels, and only authorized staffs can enter. So like that, we can also segment our network and security groups in cloud. So only the respective people can log in or access that particular environment. So if an unusual entry happens, alerts go off similar to real time. We have the threat monitoring. We have many services in different cloud, right? To check the anonymous activities. We have, like, maybe if I take AWS, we have guard duties and Azure Sentinel. So we have several services in the cloud to track this. So in cloud terms, this is about implementing multi-layered security controls. So what I'm just going to say is that one layer of security is not enough to prevent this. We need multiple layers in cloud to prevent this activity. So when we apply these cloud native best practices, we make it extremely difficult for an attacker to move around, even if they somehow get in. So, lateral movement is just not a technical term. It's a real tactical phase and an attacker's journey, actually. And unless we build an internal security walls, attackers won't just knock the door and they walk down the hallway and try every door until they find their own place, right? Okay, now to truly grasp how serious lateral movement and misconfigurations can be, let's take a couple of real-world breaches that has devastating consequences. The first one, I would say, the insurance company data breach. It was in the year 2019. So the Capital One insurance company suffered a massive data breach. What made this attack was so effective wasn't just initial intrusion, but what happened after the attacker got in is the real thing. So the root cause for this is a misconfigured web application firewall. They exposed this exposed an entry point to the cloud environment. So once the hacker was inside, they didn't just stop at what was accessible. They moved laterally within the cloud infrastructures, escalating privileges, exploiting resources, and over 100 million customer record names, addresses, credit scores, even the social security numbers were exposed. And this wasn't just a breach, it was also a wake up call, I would say. It showed the world that a single misconfigured component can, become the key to entire kingdom of the lateral movement as possible. This one, and the other one, I would say the code space attack. It's a lesser known but far more destructive breach. So code spaces was a code hosting and collaborating platform similar to what we have now GitHub and all, right? So it's similar to that. So attackers managed to gain access to that company's cloud infrastructure. And what happened next was like little catastrophic. So the attacker moved laterally across entire environment, deleting the instances, backups, snapshots, and all the information that are there in the cloud. They didn't just steal the data, I would say. They erased the company's entire operational capacity. So the code space had no adequate backup, no segmentation, no recovery strategies. So within days, the company was forced to shut down permanently. So these aren't just like a horror stories. They are clear examples of how configurations and lack of internal security can, magnify an initial data breach into a full-blown disaster. Yeah, and according to the 2024 IBM X Factor report that they have, nearly 45 percentage of the overall attacks that we have are cloud-based cyber attacks that involves lateral movement. That's almost half of all the attacks, right? So it's a clear indicator that once attackers find a way in, their next priority is to move sideways, pivoting between services, accounts to escalate access and deepen the breach. Maybe let's break down these lateral attacks. Why are they happening so frequently? So, as you could see, misconfiguration accounts for almost 33 percentage of the cloud security incidents, and also the stolen credentials comes in around 21 percentage. So these are often the results of hard-coded secrets in source code, or the credentials left in the configuration files, or even accidental exposure in the public Git repositories. That's where your credentials get stolen. So once the credentials are leaked, they act as an open invitation for all the to your infrastructure also. So it's an easy way that they could get in. So these stats should act as a wake up call to us, no matter how advanced your perimeter securities are, but you should also have the multiple layers of security that should be implemented. So what we need is a proactive and a continuous cloud hygiene, not just the reactive patching and all those things. Yeah, and as we shift gears, it's important to also recognize the attackers are evolving, and now we have AI. We all use AI in our day-to-day life, right? So AI is helping them to do it more faster and smarter. So today we see more AI-powered attacks, cyber attacks. So what they do is they scan the cloud environment at machine speeds to find vulnerabilities, misconfigurations, or any weak credentials. So it automatically deploys the adaptive malware, and to avoid any detection, it automatically fetches the credentials. It does everything for you. So and doesn't stop there. These capabilities are also the AI phishing campaigns that have the context personalized, and more convincing traditional attacks they have. So all these are now done by AI itself. Instead of we doing it, the hacker doing it manually, it's all done by AI. And another rising threat, I would say, hijacking your machine, and particularly for crypto mining currencies. So in this case, attackers compromise a cloud instance or any containers. They install crypto mining resources. They use the machine, and you'd be surprised when the billing comes up. So the billing would be skyrocketing, and they silently consume your compute resources, maybe for a week or month. And when you realize, it's too late actually. So the fundamental step is in any cyber attack is it's called as an enumeration, the process of discovering or misconfigured exposed cloud resources. And for this also we have AI tools now. So the AI tools automatically check the misconfigured tools, and you'll be able to see list out all the information that we have. Maybe I can quickly show you such a page. Uh, yeah, Praveen, can you? Yeah. So with modern tools that we have now, I can maybe this page is just an example. So this is a tool that continuously scan the internet for open cloud ports, the default credentials or over permissive settings, all that have been listed here. And you have various things like, if you can go to the IP ranges, yeah, you have various cloud providers here. And if you can go to the Amazon, and you will have all the IPv4 merged things here. This is the list of IP addresses that are exposed. So this is a free source, but you have like paid tool as well, so wherein you get even more details of what is the affected IP addresses and such details you will get it here. So yeah, maybe you can go back to the slide. Yeah. So now that we understand how lateral movement happens and how dangerous it can be, the natural question is like, how can we stop it? Right. So let's maybe I'll walk through no the few steps. Can you go to the next slide, Praveen? Yeah. So these are the few steps, which by which we can prevent the lateral movement. The first one is the least privilege access. So this is the golden rule of access management. So only give users whatever access is required, and they do not do nothing more. And over permissive accounts are one of the easiest ways for the attackers to escalate access from one's inside, right? So just give what they require. And you can also implement the RBAC, the role-based access control, and periodically we can review, audit IAM policies to remove unnecessary privileges. So this should be done in a regular, I mean, in periodic way to find out the unused. Maybe there are some user they might not need access, so this should be reviewed and audited every periodically. And the next one is to implement network segmentations and zero trust architecture. So in traditional models, internal traffic is often trusted by default. So, but this is very risky. So in a zero trust architecture, we should implement a no entity, whether either it's internal or external is trusted by default. So every access must be verified, and network segmentations is also used to isolate critical systems, so that even if one part is breached, the attackers can't move laterally to other. So this approach maybe it can prevent the potential damage and limits attackers reach, right? And we have guardrails and native cloud security services that we can make use of. And also we have to patch and update regularly. So this is one of the most common entry points for attackers. There's the unpatched softwares. It could have including the OS or the libraries or frameworks, any dependencies that they have. So the patching should be regular, and most critical vulnerabilities should be addressed promptly, and that would reduce the risk. And system left that without any patch, leaving a window, I mean, for a very long time without unpatched or of high risk. And also continuous monitoring, logging, and anomaly detection. So we should enable some real-time monitoring. We have so many tools now to monitor, log, audit, and all. So we can make use of that. And also we can use tools like CloudTrail, we can like AWS services or the Azure services. We have Azure Monitor, or we can make use of these services to continuously monitor and log the details. And yeah, the next one is conduct. We can conduct regular security audits, pen testings, and all. So we can regularly do some security assessments, as we discussed. And real world, we can go through the real world attacks and see what happened, and also how did they fix it. So these all can be now, as a regular security audits and pen testing, we can analyze and think of it like a health checkup for your cloud security posture. We can make use of this, and we can make our cloud infrastructure more stronger. So putting it all together, the lateral movement isn't just a single solution. It's about creating layers of defense across multiple identities, network, data, monitoring. So we have multiple layers in it. each layer slows down or even stops the attackers from getting inside even more, right? And yeah, can you go to the previous one? Yeah, so defense in depth. These are defense in depth. They maybe I'll give it like we have identity layer, we have network layer, compute layer, data layer. So these are the layers, and each layer they can be a breach. So, for example, in the identity layer, we have multi-factor authentication, the MFAs, SCIMs, and all that comes in. The network layer has the traffic filterings, the ingress, egress rules, security groups. That's all comes under network layer. And in compute layer, it's on the like hardened AMIs or the images that we use. And in data layer, we need to encrypt the data that are there in transit and also in rest. In application layer, we need to follow some security coding practices that would help us build this layer strong. And in orchestration layer, we secure more CI/CD pipelines and enforce some code policies. And yeah, these are the things. Yeah, so maybe I'll take a pause here and see if there are any questions that you have. Okay, I see one question from Saurav Green. Can you mention the tool name in the chat? Can you please discuss what is the most efficient configuration settings for the continuous logging and cloud? Okay, so yeah, I can post that in the chat. I'll post that. It depends on the cloud service that you use. Maybe if you're using AWS, you have like CloudWatch, X-Rays, and even now AWS has some AI related. Monitoring tools are also coming, and it's maybe in the beta phase. So we can make use of these if you're using any cloud services, or if you want to use any third parties, that is also possible. You can use third party tools. And the most efficient configuration settings for continuous logging in cloud, I would say, yeah, it doesn't, as I said, it's not just one, it's much again multi-layered. So we have to see in each layer how secured it is. And yeah, for logging, again, we have the CloudWatch in AWS. We can make use of that, and we can store the logs. Maybe we can store for some time in CloudWatch, and we can push it to an S3 to store up for a while. So these are the best practices, I would say. And yeah, and again, it depends on the cloud services that you use on how we can use it. Any other questions or anything that you have? Maybe if you want, you can unmute and ask, or you can put it in the chat. Yeah, I see one from Ruchit. Let's say in cloud architecture, we have a API gateway where we use to validate token and other microservices. We have not exposed to external world by using Kubernetes. So is there a risk of lateral movement? Any idea what more can be done to safeguard? Yeah, so for safeguarding API gateways, I would say web application firewall, we have WAFs. So in WAFs, we can create rules. We can make use of the rules in WAFs. So that would even more restrict if you see that an IP address has been hit more. Maybe you can, the WAF rule, you can block it. And by default, you can block all the rules in the WAF, and you can allow whatever is required. Maybe it's an intranet traffic or something. So that traffic alone, you can make a rule in WAF. So I would say WAF is one of the solution for all these API gateways. Yeah. Okay. So yeah, maybe we can move on to the next slide. Praveen. Okay, so let's walk through cloud attack. Maybe yeah. So yeah, let's walk through a realistic cloud attack scenario that demonstrates maybe how lateral movement attack happens. So yeah, as we this all we discussed, right, the SEM tool that we have, and the user and entity behavior analytics that we use, and these are the key metrics for monitoring and detections. And yeah, maybe we will show you an architecture of how the lateral movement attacks happens. Yeah, maybe can you move to the next slide? Yeah. So this example just shows us the importance of proper exposure control and vulnerability management in the Kubernetes environment. So imagine a typical cloud setup like this that we see in this architecture. So there's a Kubernetes cluster deployed within the cloud provider, and also there is a cluster used as a EC2 instance as a worker node, and also a pod is deployed on that node, and that pod is exposed to the internet. Likely, maybe it could be via the load balancer or node port servers or something like that. So on the surface, this seems like a normal deployment, but now let's look at what happens when things go wrong. So suppose that pod is running a web application and there is no WAF or no protection to that is in place. The application might suffer one of the OASP or they might have some vulnerabilities that are there, right? So let's say there's a cross-site scripting flaw. So this gives an attackers as an entry point. So the bad actor, that is the attacker, discovers the public IP or DNS of this exposed pod. So they interact with the app and realize it's vulnerable to this particular access. Then using the crafted malicious payloads, they inject scripts into web app that executes in the pod environment. And this script runs inside the container and may also, they can download a remote shell or they can do a reverse shell script and they can remotely access another system from here. So this is all just an entry level. So by which no, they enter into one environment and they can switch to another environments. So from this foothold, attackers can laterally move across other pods in the cluster and they try to access the metadata services in the cloud, and they from the metadata you can also steal the temporary credentials, right? And we can escalate privileges to take control of the entire node also, or even the cluster. They can also take the entire cluster into their control. So yeah, so this is the high level, and maybe we will see more on what is the enumeration, what's meant by enumeration, and also we will see a quick demo. So I like to hand over to Praveen for the next slides and for the demo. Praveen, yeah, you can take over.
Hello everyone. Just a second. So I hope is it audible? Things should be fine. So thank you, Midhun, for the wonderful informations and providing the detail, setting the stage so that I can bring a demo to top of it. So as Mithun stated that this is going to be the, kind of a architect, and while doing this kind of architectural review, I will just give a live demo of what are the part of things we can do and the process of it. So the first part is going to be the enumeration part. When I say enumeration, what is mean by the enumeration? So, say for an example, I'm just going to split. Just move between the my presentation and the GUI. Like, so the first part of enumeration would be the Nmap. Like, as Mithun previously stated that there is a one website called which is managed by Jaggers, and it's managed by the set of hackers. I mean, I would not say hackers in a uh, like they are a good actors, and they are doing a periodic scan to all the cloud instance. It's not only applicable to the AWS. It's they will do all the kind of a scanning to the across major cloud vendors. So what with that information we can do? So if you see it right, we have with this information we can see the public endpoint of that IP address of that endpoint and its host name. With that host name, can we really do anything? Obviously, yes, we can do it. So let me just take on one example. So I'm just switching between the one of the Linux terminal, and with the help of free source, there is one free source called Nmap. So what this Nmap will show is that, okay, I know the IP address or I know the host public endpoint of website which I'm planning to corrupt or which I'm planning to do a attack. So my my way of initial analysis. So what are these website as and what are the open ports? Let me just go to a simple URL like google.com. Obviously we cannot type any of our company URL. So to be generic, I'm just typing the google.com, and this system is an inbuilt with the help of the package. It will just do a scanning, and it will show the what are the list of services and what are the list of ports opened against this URL. So yeah, Now it's give at least little information about the list of URL. And I mean, this URL has what are the services like HTTP, which is not supposed to be open, but it is open. Okay, I got a lead. Another thing is like other ports also. So with this port, and say for an example, if this using this enumeration bar, I get the list of ports, and suppose that URL is not protected with any web application firewall or any other kind of uh, protection, WAF protection or not there. We can just do an kind of an initial attacks. I would say, let me just go to that point. So once I got the list of URL information and its open corresponding port, if the public endpoint is not protected with any one of the web application firewall, we can execute a cross-site scripting. What is mean by cross-site scripting? We can just with the help of the URL header, and we can manipulate with some other information stating that go to this my host machine and download a set of bash script. And once after downloading it, we can how would I put it? We can just download any kind of malicious script in that machine, and using that script, we can just do any kind of enumeration like reverse shell, and even we can take the control of the cluster. So let me just go to the again a demo part. How is it going to be? As Mithun just give a glimpse that we have a set of Kubernetes clusters, and it has a particularly one node cluster, and we are planning to attack this one node cluster. So what is the first part of it? Like let me just take it in a put it in this way that I have already with the help of the slides, I have already taken the critical information, and I'm already just put installed the malicious software in it. So using that malicious software, I'm just going to tamper get into that machine and do the all the kind of I mean, trying to get the critical informations which is not supposed to do that. So let me just take it. If you see, this machine is the node port of this Kubernetes cluster, and this is going to be my victim machine, and in the this 172 machine, which is going to be my attacker machine. So for simplicity, I have just trying to do a enumeration in a CLI, but the enumeration will be taken place in browser point. So let me take a command line. So in the enumeration process, I have identified the open ports, and with the help of open ports, I'm just going to like execute a few commands. So say for an example, in the enumeration process, I identify the port 55 is open on this machine, and adding to that, this machine also having some machine also having not protected with the WAF. So with the help of it, I'm just executed a cross-site script, and I have downloaded a netcat package in it. So using the netcat package, I'm just going to take a reverse shell on it. So what I have done it. So first, to execute a reverse shell, we just in the attacker machine, we need to execute a command, something like that netcat listening port. This can be done in via web payload. For simplicity, I'm just doing it in here. So first, I have made my attacker machine listen to that web port, and next the command going to be executed in the victim machine. So if once after executing it, just a second. Oh, my bad. I did not execute this. So that's the reason. So first I have just made the execute this command and make it into listening mode. And then I'm just execute this command. And after executing in this one, it shares it. If you see it, there is another pop out saying that it's been connected. So again, I'm saying it can be done via web payload. For simplicity, I'm just doing it. So this is going to be the my Kubernetes cluster, and this is going to be the attacker machine. So it doesn't have any kind of information. So from this attacker machine, I'm just trying to get the information about what all the resources is running. Okay, boof. It shows the list of resources like which is actually supposed to be running on the machine, which is in the Kubernetes cluster. So what are all the things running in this machine? When I say it, if you see it, I'm able to see the list of critical workloads, and which can be a web application. Okay, I just want few other information about the web application without getting it through that actual host machine. We can just take the information from remote attacker machine. So let me just try to get what all are the information we can get from this critical workload. So I'm just going to inspect this. So let's see whether is it working. Mhm. Yeah. With that, executing the information, I'm just trying to get the all the critical information of the cluster. So what does it mean? The image it's using, and the public endpoint of the cluster and its capability. And for me, this is more than enough to do it. So this is a kind of a first layer of attack. And with this information, as a bad actor, if I want to do a kind of an uh, I mean, just inject insert a malicious web page, or just make this web page completely down. With this information is more than enough for me to do it, or I can even download this image and tamper the image. And we can with this information we can do many things, like as we do. So how we can avoid it? So that's one point in it. So in this case, I have just executed into that one, and even I can just kill that container, which makes this is the actual Kubernetes cluster, and which running on the all the pods, and it can even kill it, react to it. So how we can protect it? There is a two-way of doing it. One is at the runtime level, and one is at the preventive level. So we have installed a runtime level security called guard duty. What does it do? It will just do a runtime scan. If anything malicious thing is happening, or something malicious kind of thing, it will just implement it. So before joining this session, I have just spinned up few other pods, so which can be actually created by the attacker once after penetrating into the system. So how we can just get this information in real time? So with the help of guard duty, we can just get those alerts in near real time, but it's not reactive, it's a preventive. So let me just get into the guard duties cluster. So yeah, since I have as I informed in the slide, we have just enabling the runtime security, which is going to be protect the our cluster from doing any malicious kind of attack, like how it can be done. Let me just go one more time. So yeah, this is the main attack. I have just given a gist of it. However, how we can protect, I'm just going to say what are the possible way we can just protect from someone from bad actor to get into a system. One other thing is like enabling the guard duty, which can protect our EKS cluster. So it can be a guard duty enabling is a straightforward one, but is it more or like AWS tied one? And when it's come to other services, you can also use Kevono, which will also do a runtime kind of protection. And so in this case, I just set an example if the cluster is enabled with the guard duty, and if a bad actor is trying to do an execution like Kubernetes, uh, gaining your cluster access, and they are trying to run a crypto container, and which in turns will take a lot of resources, and which in turn will increase our bill. So how it can be monitored? Because since we don't have any much monitoring it at the container level of thing, with the help of guard duty, it can protect a thing. So one, if any malicious activity done, guard duty will have a give an alert to our instance. And I mean, when I say console page, and which instance using that, we can just get a idea like, oh, something is bad is happening at our cluster level, and we can then act accordingly. But as I said, this is not a preventive one. This is a kind of a reactive one. Anything like, at least we get, if in case, if we did not have any kind of a runtime security or something, runtime security is deployed in it, even we won't be able to do anything, something like this, like someone is running any kind of a malicious query, or someone is trying to do a package with the help of runtime security, and we can do it. And maybe you can ask a question to me, Praveen. Is there any? This is a detective, which is we are doing kind of a preventive. I mean, we are doing a mitigation after attack has happened. Is there any way we can just uh, protect our resources even before doing any attacks? Like, yes, we have a many option. One is kind of a namespace security. What does namespace security mean? Namespace security is the Kubernetes native security, where in turns it has something like, what I would say. Uh, it has a baseline policy, and the policy, if any one of the user trying to execute create or execute a command or create a resource which is not abide by the policy, it will just give us it will not allow us to create the resource, or else it will give a warning, and which in turns it's going to be a near real time, and it will be monitored by the administrator of security administrator, and it will be like prevented even before getting more damages. So I will just give you one deployment and we'll see. So this is a simple deployment, but in this case, we have intentionally done a kind of a security violation, stating that we are allowing us to run the pod as a I mean, as a root user, and making it as doing it and running as zero, and it's a kind of a privileged one. So I'm just trying to deploy it, and let's see what is kind of do how is it going to react it. Yeah, it's even though it is created, it shows something, at least warning. So this warning will be triggered to that our administrator, and which in turns, like, even compared to the guard duty or runtime security, this is even more precise. Like, it will give a real-time attack, and security team can make real-time actions according to it. And this is a part of a Kubernetes namespace security, which is released in 1.30. And if you want even more secure way to do a kind of anything, something like, how we can, like, even more preventive way, or even more kind of a preventive method, I would suggest like a Krivono is that admission control policy, that will be a better one. And what else we can say? So I just want to top up few other things. So in this case, in the first slide, you see it. If you see it, we have given an open door configuration to the web application firewall. Maybe consider this as a web application firewall, and we have not defined any rules to it, and due to that, it's attacker find it easy to penetrate it, and we have just done a kind of uh, we have given an easy walkover to that system. So what can be done to avoid this? So one of the attendees just posted a question few minutes before, stating that what is the best way to just protect our public endpoint? The answer is WAF. I mean, that's going to be the one of the I would say the one of the recommended solution. Like why is it WAF meanings? Like we can just input various role to it. Like we can just create various rules, and we can associate it, and we can just make it like a negative WAF and positive WAF. We can just create it as based on our requirement. Like let me just go to one of, I mean, I will try to create one WAF without much. Okay. I'm not going to create any rule to it. So this is one of our use case, like some other WAF has been there. So what are the major misconfiguration in WAF? If anything misconfiguration in the WAF is been happen, that's a big I mean, it doesn't have any meaning of having a WAF. So how can we just protect our resource from getting the cross-site scripting? So there is a major. I mean, if we just go to the rule set with the help of with the help of managed rule set, it is managed by AWS, and we can also get a managed rule set from other vendors like cyber security and one. So in this case, we just need to protect this. I mean, enable this WAF like a bot control. When I say bot control and this kind anonymous like admin protection and core rule set. On enabling this kind of rule set, we are just making our resources protected from cross-site scripting and known bad actors. So, say for an example, if the resources which we are shown in the demo is been if it has been associated with any WAF, the intruder do not have will not be able to get into the system because it will be blocked in the WAF. So main suggestion main point is like security team need to be have like a list of information. Okay, I need to enable this and associated to the to uh, to to my endpoint before just I'm just publishing my website. So any public with the without publishing without associating with WAF, I would not recommend it the my web page to publish to outside world, because it has some large chances of getting exposed and exploited. So this is the one of the biggest misconfiguration where we can just have a greater impact. So our suggestion is something like enabling the WAF, and there is a kind of like a uh, I would say positive model and negative model. What would be the positive model and negative model? Okay, suppose my applications have a list of URL, which is I know only that set of URL is going to be added. So then I will only allow the list of URL which is going to be like my specific URL, like like application.app1. I will only allow the list of URL, and then list of the URL should be blocked. Say for an example, in there is a one kind of regular use case of URL rule builder. So I'm just going to create, for example, my application is only like google.app1. So in that the case, I will just make a strict statement saying that only match the statement saying that originated, we can just do the originated based as well as the header based. When I say header, it should only match something like exact match, and it should like app one. So if we enable this configuration one, only the URL and followed by app one will be allowed. Rest of that it will be blocked by default. So this we just need to define in this way. I know is it a bit difficult, but to protect our resource from the enhanced attack and cyber attack, we need to do a kind of a this kind of a negative modeling. So what would be the negative modeling? I'm just going to allow the list of app which are I want to expose to the public. Like say for an example, app 2 is the one of the landing page, app 3 is the one of the landing page, and the rest all are going to be my internal page. I'm not going to expose to the external world. So this is the idea behind it, and on implementing this idea, we can just gain some more like protection to our resources, which in turns will reduce the attack surface of the our environment. So yeah, I mean that's a quick one, and so that's we have it live demo. And you have any other Q&A or any other questions? Thank you, Neeraj.
Uh, there are a few questions that have come to the panelists directly. I'll probably ask those questions and then Midhun, you can take it forward, or Dhamupravin, you can take it forward. So one of the questions that we have received is, how do you see AI ML being leveraged in identifying patterns of lateral movement? Are we close to, being predictive rather than reactive?
Can you just repeat that question, Rishabh? I just lost you.
The question is, how do you see AI ML being leveraged in identifying patterns of lateral movement? Are we close to being predictive rather than reactive?
I would say like when it comes to AAML, so it's still evolving, and with the website which I have shared, it's done by the set of bots only. It's not a set of human. So having been said that, we just need to be making sure like configuring our resources with more secure way, like like only exposing the application which I want to do, and the rest all it should be blocked. So keeping an negative model WAF, and just making the like least privileges, and adding to that like making the system hardening. So it need to be a layer of checklist, like as I said that it cannot be done at the one layer. Security need to be tightened with the security groups, and adding to that we need to make WAF, and we need to make the resources it behind the firewall. So this is kind of a best recommendation we can give, because it is not easier to just directly intrude into a system. They need to break it one by one, and then they need to do it.
Got it. Okay. And just one more question that we've received, which is something similar to what you just also mentioned in terms of human element, which is, can we fully automate lateral movement detection, or will it always require a human analysis in the loop?
Um, uh, the point is like with the recent AI service of AWS Bedrock, and with the help of generative AI, we can just do it. But I would say I won't trust the AI. So, and the automation is also not fully feasible. So we just need to do an initial analysis at the high level, then only we can do. So since it is a high critical one, the better at least we should have a manual intervention at the one layer. Maybe we can it can be a just it can be an attack, but it will not, it might not affect our application. So we just need to analyze in that way. So say for an example, it can be a vulnerability, but if I am not using that package inside my system, so no use in mitigating that vulnerability or installing that package. So the answer to the question is we need a manual point at least at one point of level to avoid any misconfiguration or misinterpretation.
Okay. All right. Thank you so much, Midhun. Thank you so much, Dhamupravin, once again for graciously sharing your insights, your expertise, and for being with us for today's technology webinar. Session that you walked us through not only address the questions that we were receiving from the attendees, but also sparked a conversation, a spark to have more conversations, more discussions around around the topic, right? So thank you so much once again for being a part of today's webinar, for taking time out and driving this. We had an absolute cracker of a session. Uh, a special shout out also goes out to each and every one of you who have joined us in virtually for this particular technology webinar, for asking your questions, for making the entire session more interactive with the leaders. If you have any questions, if you require any assistance with the session that we had, the presentation, the recording, please drop us a note to events@zenov.com, and we'll take those questions forward. Thank you so much once again, everyone. Thank you to Midhun and Dhamupravin for the time that you have taken out today. We look forward to seeing you all in the future Zenov events. Take care, stay safe. Have a fantastic weekend. Thank you.